Hey guys, Mr. Bowman here. Today's learning objective is in blue, and we're learning to justify the use of a Poisson distribution. And the context that I've researched for us today are about the average number of puppies per litter. So, in a 2011 paper or research, they analyzed over 10,000 litters of puppies, including 224 breeds, and they found that the average litter size was 5.4. And what we need to do is we need to think, well, is it appropriate or will we have reliable estimates of probabilities if we use a Poisson distribution for the number of puppies per litter? And what we're going to do is we're going to start off with question one, which is a pretty insightful question, and we're going to change pen colors to yellow. And it's asked us, choose an appropriate model for the number of puppies per litter, and make sure you justify your answer. So that last part is important. So obviously we're looking at Poisson distribution, and that has 5 assumptions. So the first assumption is it must be discrete data. So what we need to do is we need to just discuss, are the number of puppies per litter discrete? And of course they are. You can't have part of a puppy in a given birth. You either have a whole puppy or a no puppy. So what we can say is we can say the number of puppies per litter is a discrete variable. And that is our first assumption. So that looks like a bit of a tick. Obviously, in your example, when you're writing, don't tick and cross as you go, but we're just noting that's a tick. It looks like we've satisfied that assumption. So the next one are the variables. They must be independent, or each litter must be independent from one another. And in our case, 1 litter of puppies, well, that's not going to impact the number of puppies that are born in the next litter. So that does suggest that it's independent. So the number of puppies in 1 litter is not going to impact the number of puppies in the next litter. Okay, the assumption after this is it must be unpredictable. And what that means is there mustn't be a way of guessing, or there mustn't be a pattern that you can use to have a really good crack at the number of puppies in the litter of a given puppy or a given dog. And what we're going to do here is we're just going to, from now on, I'm just going to start pausing the video. I'm going to write it up, and then we'll get into the next assumption as well. So what I've written there is there is no reliable way to predict the number of puppies in a given litter. And that also suggests that we've met that assumption as well. So it looks like we're 3 from 3 so far. The next assumption is they cannot occur simultaneously. So they cannot occur simultaneously, and what that means is you can't have 2 litters at the same time. And what I've written there is I've written all puppies born at the same time relate to 1 litter, which suggests we cannot have simultaneous litters. And that refers to one kind of mother dog. All the puppies born at that particular time, or for that related to that particular birth, they all relate to the same litter. We can't have simultaneous litters from that puppy or from that dog. And the last assumption is events must be proportional to the interval. And what that means is I would expect more puppies from 2 births than 1 birth. And if I increase that interval to 3 births, I would expect even more puppies. 4 births, even more puppies again. So 5 litters, there'll be more puppies. So the idea is the more litters we have, the more and more puppies that we would expect. And what I've written is the number of puppies should increase as the number of litters increases. And that's just demonstrating that it is proportional to the interval that we're looking at. And what we can do is, now that we've gone through all 5 assumptions, and in this example they've all been ticked, that won't always be the case, we can make a bit of a conclusion. As a result, it appears that the number of puppies per litter could be modeled by a Poisson distribution. And what we've done there is, from start to finish, we've chosen our appropriate model, which was a Poisson distribution down the bottom. And we've gone through each of the 5 assumptions just to test or to check that the assumptions are relevant to the context that we're looking at. So I just want to note this was a very slam dunk case. All 5 out of 5 were clearly met, but there will be times, particularly to do with independence and the ability to predict, where those assumptions may not always be satisfied. So what I'm going to do is I'm going to rub out the last portion of our discussion, so we have room to do the next 3 questions. But what I also suggest you is, if you haven't got this example down, please pause the video, write down the context, and write down some key notes from our discussion. Okay, we're back. Hopefully you got all those notes, all those examples down. So we're now going to get into the actual math side of things. Question 2. The first question, question 2, what's the probability of getting only 1 puppy? And so what that means is X being the number of puppies we're interested in. That's going to be exactly 1. The lambda, well, here we don't have any details about how many births, but I'm going to assume that's just from 1 litter. So I'm going to assume that the lambda is 5.4. Because we're looking at an exact or an equals scenario, we're going to be using the PPD mode of our calculator. And just going to plug that into my one right now. PPD, so X is equal to 1, the mean is equal to 5.4, and that means the probability of getting 1 birth is equal to 0.0244, and that was rounded to 4 dp. So 1 puppy in a birth, pretty unlikely to happen, just over 2%, 2.5%. for that to happen. So question 3. What percentage of births will result in 5 or less puppies? So that keyword 5 or less, so that means we're dealing with a range of numbers. We're not just dealing with 1, we're dealing with multiple numbers. So let's draw a number line just to make sure we've got it correct. And I do want to note this number line is really important. Those of us who don't do this will make heaps of mistakes and get the wrong X value. So 5 or less, so let's circle that. So 5 or less will include 5, I think. So we're going to circle all these. And the highest value in the range we're interested in is 5. So that means X will be equal to 5. Again, we're going to assume, or carry on with our assumption of 1 litter. So that means our lambda is 5.4. And because we're dealing with multiple numbers, we're interested in 1, 2, 3, 4, and 5. We're going to do the cumulative PCD mode, and that means the probability of X having 5 or less would be distributions Poisson PCD, X is equal to 5, lambda is 5.4, the probability of that 0.546 and 1, and that's also rounded to 4 dp. And the last question, what is the probability in getting at least 10 puppies over 2 births? So over 2 births, we've now changed one of our assumptions, our lambda. So let's do that. So let's go 0, 1, ... 8, 9, 10, 11, 12, 13, and we'll just carry ... again. So let's circle the portion that we're interested in, at least 10. So we've got to ask ourselves, does that include 10? In this case, I think it does again. So that's our range. And that means 10 is included. The only issue is our calculator works from 0 onwards. So we've actually got to calculate the area below that, of which 9 is the highest. So x is going to be equal to 9. Our lambda is now going to be 10.8. And we are using PCD mode. And that means the probability of x being 9 or less, well, that's going to be equal to, so x value of 9, lambda of 10.8, that's going to be 0.3626. And now that we've got the lower end, we can then go ahead and calculate the probability of the upper end. So the probability of x being equal to or above 10 is equal to 1 minus that probability we just calculated. And that is going to be equal to 0.6374. And we've just run out of room as well. So hopefully you found this video useful. What we did is we looked at, or we ran through the 5 assumptions to assess whether or not a Poisson distribution was appropriate. And then we went through one of each question, an exact question, a less than question, and a greater than question. So hopefully you found today's video useful. Now let's get into heaps of questions.